with you?
It's pretty good. It's pretty good. Being able to melt something is sort of a big deal for me, anyway. So, just gonna see. All right. So. Trying to rearrange windows so that we don't get lost here. Now I'm just going to share my screen. I can't really... I can only share my entire screen, which is weird because it's going to share you as well. Anyway, whatever. Of interest, the windows on the left. Can you read the text on them, or is it too small?
Yeah, let me make my screen bigger. Yeah, I can read it.
Yeah, okay. So, what I've got going on is in the command line here, this is the command line version of DOS.
Okay.
I can do, when this boots, it fires up a chain that has memory. So when I do ls, I have the, hang on a second. I was being lazy and I did a console log somewhere. Sorry about that. Console.log, because I love doing that. Now, here it is. Okay, from the top. So, boots have a chain. Each command is turned into the shell covenant.
Mm-hmm.
When I do ls at any place in the path, I get all the files in the file system, but I also get the functions that are available at that chain point as well.
Mm-hmm.
I can add chains, so I can go add whoops. Did I already make a chain yet? I'm gonna... Sorry about this.
Hey, no worries.
I need to remove my memory because part of the problem of having memory is that as I make modifications to how the core works, suddenly things aren't so relevant. But the point is that, okay, so I can go, I can add a chain here. It shows up in the list. I can change to the chain, cd boop, ls. I can ping it. I can also ping the root. I can exit the program back to the normal terminal, and I can start the terminal again, and I have my current directory is preserved, the chain is preserved, and I can still ping it. So memory is great.
Yeah, that's great. That's
yeah.
I like the time blocks, chains, blocks plus chains plus. That's helpful. That's
Yeah, I know.
especially
It's like,
when you start making like 1,000 things. That's going to be
yeah, I know. Yeah. So I can add, nested things, like, another chain there. Go back to root, do all this stuff. Each time it's making a new block, and basically this is just a CLI interface to the block making engine.
Mhm.
All the commands are happening as interactions through the shell, which is great because it means you can control it remotely.
Yeah.
And the API for the shell is in pure JSON schema. So the covenant is read. So it's basically, you can read the commands available to you in a remote chain without executing any untrusted code. You're just reading JSON. It also means that what I hope to add is on the CLI, I can add autocomplete for not just command names, but also command parameters, as well as the help being included by default with the covenant. Plus I can make web components that will be able to auto deduce what the available inputs are and input types using JSON schema form. So it basically gives you, if you just write your code, you'll get a crappy GUI for free. And then, you can add more on top of that as well. Now, this window here is the same code running in the browser. Let me just dump my database because I just can tell that's going to be a problem.
That means the blockchain is working. You're haunted by old decisions.
Yeah. Permanence, right? So I haven't added the delete database command into the shell just yet. Of two minds whether or not it belongs there. It's basically like commit harikari and dump everything you ever knew about yourself. Okay, so I just booted a new chain in the browser. I can add another chain like so. And then I can refresh the page and it's still there.
Cool.
Yeah.
Is the shell like a chain too?
The shell is a chain, yes. The shell is a covenant in the chain where the chain's path is /.
Oh, okay. That makes sense.
Yeah. And one of the major design decisions I made over the past few weeks is that the concept of latest is only stored in one place, and that is the latest of the root block.
Okay.
As a consequence, whenever there's a change within the file system tree, those changes must be propagated up to their parents so that ultimately there's a new root block made and latest is stored so that when you recover it, the view of the system is as the view from the root. If you made a change to a chain and it didn't make it up to the root, it's lost.
Right. What kind? Is that going to introduce a lot of latency into the system?
No, because it's only for crash recovery that you need that rollup. So the latency remains the same. It adds some extra chain generation in there. That's basically, I think it's roughly the log of the depth of your chain, roughly. So it's not, it's not bad. Certainly not exponential. But yeah, it seemed okay. It's certainly not a noticeable impact, and it only really has impact when the tree gets deep.
Mhm. And what if multiple people are like changing the same target from two different places? Like, um, is there any potential for data races or echo or anything like that?
No, because you have to modify the chain, you have to acquire lock on the crypto key.
Mhm.
And so only one engine can be making a modification to that chain at a time. If say two sibling chains deep down the tree make a new pulse, the update to parent will be pulled together. So it's not
Mhm.
it's so they do combine on the way up. So you can get, like I believe the speed up, the impact on performance will be near zero because of the fact that you can combine those roll ups.
Right. Yeah. Yeah. I mean, it sounds like sound a sound idea. Yeah.
Yeah, but why I'm wanting to touch on that is there was a weird. It's not even a quirk. It's like something I don't think we ever considered before. If you have an app complex of an arbitrarily large number of chains and you are forced to restart, you don't know if a chain is belonging to your app complex and you're the validator of it. You don't know, you don't know how to find any of the other addresses in the system.
Mhm.
So I've made the call that pathing is actually, it's not just sugar. Pathing
Right.
is now critical in the system because
Okay.
pathing is how, like, knowing where root is up to is a
Mhm.
reasonable thing to expect, and it's also practically zero performance cost. Knowing where every other chain is up to in the system is, you can't expect to know that directly. You can only know that by walking from root.
Right.
And
Um,
yeah, so that's why pathing becomes like, it's not
it's not
just,
an it's not an overlay anymore, right?
nah, it's actually how you find the chains in the system. And this same problem is compounded when you do remote mounts. So the system I've put in place for connecting to foreign chains, um, if I go, for example, who am I? It tells me the chain ID of the root chain. So
Mhm.
that's my root identity. The peer ID of the machine. So that's basically the validator public key, which I've also made as the libp2p peer ID. That's also used for connections to
Mhm.
encrypt the connections between peers as well.
No,
It,
that's a good idea. It's like your IP address and MAC address in one.
yeah, man. Um, that's borrowed directly from libp2p's concept, but I also made it be the validator key as well. So it's
Mhm.
all one thing. Uh, if I do who am I on the Node.js version, I also get these addresses, and um, these addresses are IPFS multi-format addresses.
Mhm.
They are, if you sort of said to yourself that the covenant format was really the winning thing that ever came out of all our effort on all the previous blockchains before,
Mhm.
multi-formats would be the one thing that IPFS and libp2p have contributed that is substantial. Like, it's basically a string that can be used to address any type of known network protocol with a secure endpoint, because you've got the public key of the node you're expecting to find at that address as well.
If that's part of the address. That's
Yeah.
the last string there.
Yeah, it's amazing. Like, it's a great idea.
Yeah.
And so I can basically add arbitrarily many different types of transport. This one is just simply IPv4 TCP, but they've got transports for QUIC, for WebRTC, all kinds of things, right? So basically it all fits this format. So with this one string, I know that, this is, I can find this guy.
Yeah, it lifts all the network details up to the key level, basically, right?
Yeah.
Yeah,
So
it's cool.
one of the there's been a number of strange problems that I hit while trying to do remote mounting. And what I was interested to talk to you about was just make sure that the decisions and assumptions I made don't seem odd. It is too much load to, if you imagine a mega chain app complex, so there's a million blockchains in one complex. It's too large to store IP information about every single chain.
So one question I have there immediately is it likely that there will ever be a million chain application that has like a vast number of validators on it?
A vast number of disjoint validators, or a vast number of, I don't think that, I think that an app complex is defined by a single validator set.
Yeah.
I think it's a different, because I've started to treat chains that are inside the complex as very different to chains that are outside the complex. And that was one of the concepts we started touching on in Minx, where we were saying, well, you can kind of speed up the processing time if you process everything that you know is internal and then move its actions around and all that, because you don't need to like stop and then wait. You can just keep running because you know that they're all your chains.
Yeah.
And ultimately, and so what I'm hoping is that when you do that, like, eager validation, each validator only needs to transmit its new proposed route out to everyone else, and then they can sort of figure it all. You don't need to transmit each and every little proposed chain. You're just like, here's my route proposal, and you can use that route proposal to get the diffs of everything else in the tree. I am looking to add a concept called tension, where tension is a crash recovery mechanism. Tension means that you have got some outstanding request to some other chain that could be local or remote that has not settled. You may have received a promise for it, or you may have not received a promise, but either way, it hasn't been settled. And I want to roll that up to the root, so that from root, I should be able to walk down and find every chain that has something outstanding. Because if there's a crash, it's arbitrary where I got up to in my own internal processing. And so I need to restart from looking at who's waiting for what and start rolling backwards from there. And sort of the argument I have with myself is, if you had multiple validators, could you not care about that and just assume that at least one system is online? Or is it?
I think that's an extremely dangerous decision.
Okay, good. All right. So basically, as soon as you can, you should write some crash recovery data down to disk, right? Yeah. So basically, recover from as close to the crash point as you possibly can at all times is a good principle to put into the system, right?
Mm-hmm. Can I? It feels like we're seeing the host chain again, basically.
I think, yeah.
Where I got to, I mean, I want to avoid it, right? Because it's like a mind virus that immediately destroys everything, right?
It's like it's basically microphone echo.
Mm-hmm. Where we got to when we were working on this before was this was the reason that we made this was something we were thinking about a lot when we were making the loopback interface inside of a chain, is like, could this be used for a host chain, right? Like if you made a rule that like whenever you're blocking a bunch of small things that you know are in your domain of control, like if you always suck the actions out of them and then like record them on the loopback interface of the parent, in this case the parent is like an execution context and not like a node that made a child. So I need to kind of distinguish there. I don't think parent is the right word. But like if you were trying to make the blocking process run inside of a chain, right?
Yep. So if you're trying to run the engine as a covenant inside a blockchain.
There's multiple different versions of the same thing that kind of popped up over time, right? And like we talked about translating the code into blockchain code before we started. We also talked about this host chain concept where like all the chains that were running inside the host chain were capable of being blocked inside one, like from the outside inside one synchronous frame, basically, without like having the async breaks. And the chains inside were, the way we talked about them is that they would run for as long as they need to, and then they would be squashed. And then the squashes would be like the new next block for the host chain.
Right. Okay. So that in a way, a portion of that can be satisfied by the root pulse, because that represents the squash of everything, just wherever they got up to, and then you're like, here's the root.
Mm-hmm. What we noticed is that, like, if you made the host chain a chain, then basically when it had, and this was a very strong reason why I thought that the loopback interface should be asynchronous, because I think that would basically give you recovery for free. But if the loopback interface basically pulled all the actions out of all the inner chains and then pushed it through that loopback interface just for redirection to the correct chain that it needed to go to, then if anything in that system crashed, you would always have a record of what was in flight that you could recover from if you just rebooted the host.
I think I see what you're saying, and to translate it into the architecture I've applied here, there is an interpulse queue, which is any interchain communication. It creates an interpulse that is queued up within the engine to be processed as soon as possible. I think that's what you're talking about, the loopback interface being. So that the host chain actually can write down what interpulses it is up to processing. So crash recovery is not, as I'm saying it, it's not finding the pulse and then working out where it got up to and all that. You've got the interpulses itself sitting there ready to go.
Right.
You can just carry on processing, right?
Right. And if you keep a record of what you processed on the child chains or the far paths in the complex, it's very easy to make it idempotent. It's very easy to make it so that if I accidentally picked up and reapplied a bunch of actions that were already applied, they just were no ops at that point.
Yeah, I think idempotency is an important feature of the engine, but I've left it out on purpose because it's a great signal of a problem. Because there's only very narrow times when the idempotency should be required.
Yeah.
And I actually can't think of any except for I fucked up somewhere
Right.
so far, right? So that's why, yes, idempotency is what I've tried to do is separate out. You definitely need idempotency when you're dealing with a remote validator,
Mhm.
because you may receive signals from them out of order or malicious signals, and so you need to be able to rearrange them. But I've done well at keeping the engine pure. The
Mhm.
engine expects coherency from the interpulse queue or the loopback interface that you're talking about. It
Right.
expects that another process has already vetted everything in there to be not out of order,
Right.
which you can do if you've got storage. You can know that, look, this is odd.
Yeah. Yeah. Okay. I mean, um, you're 100% right. If you build a system that like tolerates too much fucking around, then it causes you to write it causes you to write bad code, right?
Yeah, hides the bugs.
Yeah. And you don't
Um,
necessarily want that until you need it, right?
where that actually caused problems for me earliest was the fact that I would get Node would crash saying that a promise had rejected, but it wasn't caught, and that's where that idempotency can sort of fail. So what I've got here is when you pierce into the root chain with an
Mhm.
external effect, if you await that, you're not just awaiting the result from that, you're also able to await the engine itself settling, which implies, to use your language, that the loopback queue is empty.
Mhm.
And awaiting an empty loopback or an empty still to process
Mhm.
queue is useful, I think, because
Yeah.
I can await all the processing, and then I can await the storage layer, and then I'm like, you can turn me off now.
Mhm. Right. Yeah. No, I mean, it sounds like basically the same thing. It sounds like, you know, the two
It's not.
pieces there are,
I'm not doing what you suggested, and I need to think about how to do it, because it sounds like an alternate way. Because that interpulse queue or the loopback interface is only in RAM for this
Mhm.
implementation, and so when it dies, it completely, you got to rebuild it. Whereas what
Right.
you're talking about is like treat it as a first class part of the root pulse,
Yeah. Yeah.
and then
Yeah.
you have that issue.
Right. That's like where I was asking a bunch of questions before about how much the root is actually responsible for routing things. Because like the way I had always thought of the host chain is basically like it's like the mailman, and it has a bunch of letters in its bag, and
Yep.
if the like if anything dies under the mailman, like you could just ask the mailman to go back through the letters.
Yeah.
So,
Yeah. I definitely don't have that feature there, but
mhm,
you're right. That was a benefit of the host chain.
mhm. Yeah, you have like I mean its entire job to me felt like it was basically just an addressing like coherency mechanism.
Mm.
Whereas the root here, I think it's kind of doing a lot of the same things the way you described the
Yeah.
root. It's like it's here to like give you your sense of how like how time is ticking along for this particular
It was
application.
the where it started, and still its primary purpose is to allow reproducible queries across the app complex.
Hmm.
So if I want to query every customer, it's going to depend on what the hash of the root chain was at the point in time I asked that question.
Hmm.
And so that's its primary purpose, is to make reproducible queries.
Yeah, yeah. Which I mean, it's I don't know if you squint, it's like kind of the same problem, right? Like what
Yeah.
like keeping track of like who's doing what when is the same thing as keeping track of like what happened in time and like where everyone is up to.
Except the addition you're talking about is adding some of the mechanics of the engine as part of the blocks or pulse structure of the root pulse. Whereas I'm talking about the system as it is right now, I'm proposing that I rebuild that state through a torturous type of inspection, plus adding some extra overhead on each update that gets rolled up to the root. Whereas you're talking about don't do the rolling updates, just keep it all in one big pipe and periodically write the pipe.
Right. But then you also have like I think there's some kind of concept here of like it's like a higher order single point of failure. Like one thing that does too much stuff that like even if it's being run by multiple different machines, like it's still kind of like a logical bottleneck to the system.
Yeah, it does. It does kind of choke it. However, the bottleneck's still there, whether you write it or not. You know, like it's the engine.
But are you making the client pay the cost, or are you making, I guess there isn't clients and servers, there's just nodes. I understand that. But like, are you distributing the cost, I guess, around the network of recovery?
Yeah. I don't know the answer. I need to think about that. It's a sailing close to the edge of where the host chain starts and why it's there is always like it's easy to fall off the rail on that one. I've got this far without the host chain, and my plan was always like, I can run this engine as a covenant inside a Pulse chain because I can use resources like storage as another chain and just connect it in, and then it runs and it doesn't know any different. So, but that's one way to do it.
So I actually think that the host chain is probably like trying to make that thing would be like a code suicide pact. I mean, I think it's going to be something that like if it's even possible to make, it's going to require a lot of system knowledge in order to start the process, right? Like it's a better design decision to try and like make this all much more direct. Like it doesn't need a level of abstraction like that makes it,
I guess I've lost sight a little bit of what the purpose of it was, because I've managed to get a lot of the features I was after out, like the shell. The shell is a covenant that contains all the behavior that as a developer I'm going to call on. That's kind of does one of the major reasons for writing the engine itself as a blockchain. Also, the engine came out pretty simple after having pulled out the IPFS layer and the libp2p layer. So I'm like, even that's sort of a bit different. But you're right, I am sailing very close to the host chain, and I just
the root always felt like it was kind of shared some of the genetics, I guess. I'm fully 100% in support and agreement of like never writing the host chain. I think it's probably possible to split it into 2 things that are not insane, or 5 things that are not insane, versus one thing that's like as insane as it could possibly be, right?
Yeah, but temptation.
So like it was the outgrowth of a very long discussion about like to what extent should we be making the code capable of running inside the runtime of the system as like a way of exercising that the system is truly like a general purpose compute engine.
That is a good reason to do it.
But there's a lot of easier ways to prove you have a general purpose compute engine, right?
No, because we bring time travel debugging to the covenants. It is currently quite a burden to track down bugs in the engine because of the fact that it's code that loops a lot. And then when you got an error in like loop 47, it's like, how do I get the system into the state of how do I even know that it's loop 47 to start with, right? Whereas if I had the host chain, I should be able to load it up in a known good version of the engine and then navigate forward and back in history and like run the engine with a very definite context to reproduce what I'm looking for.
Yeah, and like it's a good aspirational goal. I don't think you should let it block you making an application that has customer value at this point.
Yeah, the application with customers is a great sort of a razor to cut down. Do I need this or not?
And again, like I'll always think of it in terms of making a language because that's what I felt like I was doing. Usually, the first time you make the language, you don't make it in the language code. Usually, the first time you make the language, you make it like in some other language's code, and then you write a compiler in the language.
Yeah, it's definitely true. Okay, so to add further impetus, basically, to what you're saying, the way that I connect to a foreign chain is that I use the command, I go add, where is my computer is dying. I go add peer, and then I add I think I add the address first. So I'll add, I don't know why my computer's being really difficult while I'm using this video application. It's like the most frustrating thing ever. So I basically have to, I have to add a mapping between a peer ID and a chain ID. And I need to store that somewhere. And that starts to touch on that philosophical debate in libp2p, which is in order to be a good offline first networking library, you need to have some memory, because when you lose your net or you reboot, you have a lot of contextual information about the network that you're in that lets you restart rapidly. Now, there appear to be 3 bits of information that we need to enter into the system that cannot have come from within the system itself. The first is what chain ID do I want to connect to? You need to have received that somehow. Then you need to know what is at least one of the validator peer IDs.
Does it need to be a validator? Can it be a consumer?
There is no such thing. Maybe, but I've really sort of dropped the concept of consumer and said there's only validators. If you were just a witness to a chain, then you should have been a validator on a chain that was a witness to that other chain.
Validator on a chain. So a witness. Okay. Wow.
Right.
Can I unpack that one a little bit?
Yeah.
Like a witness in this case is not just a type of node. A witness, like the way you're describing it, sounds like has to be running in chain land somewhere.
No. A witness now would be a node that has read access to an app complex or part of it.
Right. In which case, I guess they're still going through their shell, right?
They're represented by a chain, and the permissions were granted to a chain. Now, I could later expand that definition that, it'd be like trying to talk to someone by getting in touch with their third cousin first. and then working your way back. So yeah, we could add that functionality in. Right now, I've just made the simplification that look, you need to know a validator peer ID on that chain to be able to interact with that chain.
Yeah, I suppose that like I guess I worry that things like that are a fan-in, but it's not something that you need to worry about. Like if you're validating a chain that a lot of people are interested in, you should provide resources to your computer, right? You should be able to accept a lot of inbound network connections. You should be able to, relaying and gossip is like a different problem altogether. Basically, you always try.
Those are problems that come in when we have large numbers of nodes, and that's something that the DHT can help us with.
Okay.
Because you do not need a direct connection to it. The simplification I've taken here is we are dealing with a small network, so we're dealing with like 10 computers, and we are, for the meantime, dealing with a server.
Great. I don't want to hang this up anymore. There's a third piece of information. I agree with your decision to make it that I need to know a validator address.
Right. Okay, so I'll in the future, you would need to know a participant peer ID. For now, you need to know a validator peer ID. The third piece of information you need that you should store is the multi-address strings that allow you to use conventional transports to reach that validator or that participant.
Right.
And those are bits of information that, it's a tough decision. Do they belong in the chain or do they belong off chain? And so I went with on chain because I'm like, well, the whole computer needs to go in the chain. So that's part of the computer, and it goes. I made a concept called MTAB, where there's a dedicated chain /MTAB that represents mount data.
Okay.
And this is another reason why pathing has been escalated from nice to have to essential, in that if I am a deeply nested chain in the app complex and I want to talk to a remote chain, I have banned the use of talking to an address directly. You must talk to a path.
Okay.
That path, if it's foreign, that path needs to go through MTAB.
Yeah, that means there's a mandatory mounting process, right?
Mandatory mount. Yeah, you have to mount. You can't just talk to a blind address, because how would I know those 3 bits of information about that blind address on restart?
Right.
Should I make it that you had to add it in your chain when you talk to them? What if there's duplication throughout the app complex? It just seems cleaner and nicer to store it in one place, because sorry.
It seems like it's going to work out better for security in the long run too.
Yeah, but it's also again, this crash recovery or restart has sort of bumped right up on my priority list. I didn't think it really needed to be considered that much, but when you do a restart and you've got a million chains, you don't know which one was waiting on something from something remote. You don't know if you should go and restart looking at the broader network for other validators that the chains that you are looking after have requirements to talk to. So having all that in a dedicated spot, when the computer boots, it looks at MTAB and then gets the address information and transport information it needs to reach out using physical transports to begin the subscription process to these remote chains. And then that means that I can restart quicker than having to walk the entire app complex and look for anyone who might have made a connection at some point.
It also kind of feels like it logically centralizes security related concerns, right? Like now I can ask the person who's sending me a message if they're, an MTAB covenant, and like, do they know how to do the MTAB handshake properly? And like, you can obviously copy that process in any other code unit you want, but like, it feels like it's going to be an easier place to put, like
What did you
mounting
mean?
right now.
Security. What did you mean security?
Right. What I mean is, like, again, I always try to represent this perspective that like we're gonna run into all the exact same problems that people had when they made traditional applications, right? It's just they're going to
100%.
be happening in chain land.
Yep.
So yeah, so like if you just try to like randomly start pulling up addresses like in hardware systems or on network systems, without going through any sort of like formal handshake process, like most of them will just reject you, right?
Yep.
If you're on your machine and you start trying to mount something that's like not a drive that you have permission to mount, you're never going to be able to do it, right? And that's because it needs to be accepted by the mounting code, and then the mounted code needs to be accepted as well, right?
Yep. But it's the reason, as a user of a mounted path, it makes no difference to me. I'm just talking to another path. It's the system that is assisted by this formality, not the user, I think.
Sorry, and I'm talking about code as people again. My mistake.
Okay.
Right. Like what I mean is, like, if you had this process before of just like kind of blindly reaching out to a random address in order to link things together, like that means you're doing it through mostly like user impulse, right? Like there's no extra layer there where like my intent to connect to something is expressed, and then like some sort of interface in between is invoked, and like that intent is expressed in a more formal way through an interface. If you make a mounting code unit inside the shell, which I assume where you're putting it,
it's exactly where it is. Yeah, it's the command mount. So you can see it here, mount.
What I'm trying to get at is, like, now you have a logical place in your shell code where like you have an agent that's like acting on behalf of your intent with regards to the rest of the network, which means
it reads the config from MTAB, and then it seeks to satisfy the implied request in there as best it can.
And not only that, when it does it, when you actually mount and you like start loading remote data in, like you can make a very thorough process to vet like whether that connection is supposed to exist. You could have done that before in the shell code, like no problem. It's just that you probably wouldn't have centralized that logic if you were just sticking it in random areas.
Yeah.
Like it feels like what I'm trying to get at ultimately is it feels like it was maybe a missing piece before. It sounds like a good design decision.
Right. It definitely was missing before. I had the simplistic view that we just bolt bits in from all over the place. And then I was like, actually, we need peer ID and addressing information. And then, the Linux kernel has that solved for us with MTAB. Let's just follow that lead. My question to you is, does that still scale?
Yeah, well, I mean, that chain's going to get fat very fast, right? Like, I would imagine it actually probably has hundreds of records on it at any given moment in time.
Well, not for the CRM app.
No.
For the CRM app, it has exactly one record,
which is the sole validator, the server.
Yeah.
Okay. Yeah, but I mean, in any normal use case, like in the steady state operation of the system in the future, you probably use 20 apps on your phone at the same time, right?
Oh, right. Yeah, I see what you mean. Okay, so you'd probably have about 200,
Yeah. And now
200
it's a
inches or something.
and now it's a chain, and we have to assume that there's validator churn, right? Like, and it's relatively frequent. I'm not so worried about whether it's like huge and slows everything down as much as I'm worried about it introduces a new type of data race into the system,
A data race. What do
like
you?
where the live system is full of validators that are churning faster than it can reach my MTab.
Oh, right, right. Because there's like an OODA loop. There's like an update loop that. Yeah, that's an interesting point.
But it will also be big because these addresses are huge, and um, it is a chain still. So you're going to have to figure out some sort of like ejection, I think, for it.
Oh no, that's done already. This
Is it?
can, yeah, because remember how I used the hash array map try to represent network channels so that
Mhm.
adding is constant time no matter what the size of the chain, or log time, close enough, no matter what the size is. So
Mhm.
the place that I store what is the latest pulse and what is the address is just in a channel.
Mhm.
And it's what's special about MTAB channels is they're channels that go nowhere. They're channels that require an external service to update as opposed to something internal. So
Right.
the number of channels is kind of irrelevant to the speed. Um,
Right.
so we've sort of got that on our side. Um,
Yeah. I mean, I don't know. I I don't foresee any like monster problems with it.
okay,
I do
okay,
think that adding a chain adds a certain amount of like latency that you need to think
yeah,
about,
yeah,
you know, whether the live situation you're trying to model is changing too fast. But
yeah.
in this case, like how fast do you expect people to be changing their validator networks?
Not like that should be like a yearly type of a thing, not much more, right?
Well, and even so, I think you have a physical constraint that works on your side there too, because like to change a validator set on a chain that has a lot of, or on a complex that has a lot of validators is always going to be slower than changing data on my shell chain that has one validator.
Mm,
Like
yeah,
my frequency is higher than like a validated app's frequency.
I yes. I also have hopes that once we get to that sort of scale, we can take advantage of things like a DHT to
Mhm.
provide a sort of a less concrete representation.
Mhm.
This I guess would be more like the bootstrap list, which would be like if you want to get started with this chain,
Mhm.
use these nodes to fetch DHT records and then build up from there.
Yeah, right. So this is like just getting you even into the DHT. That's a
Mm,
yeah, that's an okay way to use it too.
mm. Okay. Well, and I guess the thing I was checking with you was that now like for the engine to decide whether it needs to send the interpulse remotely
Mhm.
or internally, I now look at the path only.
Right.
And that's really the question, right? Like pathing is now this message is going off machine or not based on its path. Pathing is no longer syntactic sugar. It is now first class.
Yeah. How does this impact like symbolic linking and stuff?
Symlinking I've defined as being a local path, so like a no forward slashes involved,
Hmm.
um, mapping to a path that can be arbitrary.
Right.
So you
Local
can
or
yeah, so you can symlink remote or you can symlink local. That's totally fine. Hard linking I've set as it is uh, a direct child. So no, you have to be in the same directory, and
Mhm.
it points to an address. And so far, I'm saying that the only place you're allowed to hard link is in the mtab file. And that's sort of where things are feeling a bit weird, but I don't have any other use for a hard link.
Right. I guess I never had a use for a hard link in anything I've ever built on a Linux system. So
Yeah.
I'm still not 100% sure like why they're there.
Well, one very useful case for us is that you can allow two parents to exist for a single child, such that if one parent deletes its child, it automatically becomes a parent of the other. And that's how hard linking in Linux works, kind of, is that you can have a file technically exist in both places. If you remove it from one, it's still in the other.
Right.
Whereas a symlink's not like that. Symlink doesn't behave like that.
Yeah, actually, that strikes me as a politically useful mechanism.
Yeah.
If you wanted to kind of like change the governance model of a piece of data in a way that's like kind of irreproachable,
there's a lot of weird questions that come up though, because in our system, I've said that parents have absolute control over children. And if you've got two parents, do you now need to reach quorum to have control over the child? Who's paying the bill, right? And so the best thing I came up with was there's like a primary parent, and then whoever hard second is like the backup parent, and you're the parent until you decide not to be, and then it just falls back to the next hard link.
Yeah, I mean, I think that makes sense.
It's ugly, but yeah.
Yeah, I mean, quorum. The next wave of the fractals starting already.
Yeah, right. It's that's basically just zooming and zooming and zooming, and that's why I felt that mounting was such a big deal, because it's opened up so many more problems or opportunities, depending on, or it's required a lot more specifics from the system.
Right.
Like
so sorry, go ahead.
No, I finished.
How do you tell when a chain is remote? Like by the path. It's like in this. Yeah, so it's like /MNT/ whatever.
Yeah, it somehow went like, you can walk the path all you like, but as soon as you go through mtab, you're remote.
Yeah. Right.
Issues with that is if I mount something over here and then I mount it over here, and it actually has now a link back to that other thing, I can cause this sort of, it'd be like mounting a network share on a network share and then sharing it back to the original computer. So there's that kind of issue to deal with. At the moment, I'm just like, don't be dumb. Please don't do that. I don't know how to. You probably need some kind of spanning tree system.
Yeah, you can detect it for sure.
Yeah.
You could send a fish hook action through to see if it gets itself.
Yeah, true. True.
Shoot yourself in the back of the head through the wormhole.
And so basically what I was going to do is when you're in the system and you go, you're like, first of all, you got to go add peer, and you got to add, like, say, this chain ID and this peer ID. And then I would go, like, I haven't implemented this command yet, but I'd go add address, and then I'd put in the peer ID and then the multi-address string here, like that. So I'd go add address, add address, peer ID, some strings for the transport. And then from that point on, the code that I wrote is always trying. Like it knows what it's been asked to do, and it's just trying as best it can with the information it has. When I give it the 3 pieces of information, it can begin reaching out to that, making a connection to that peer. And then when it gets a connection to the peer, it asks for that chain, and then it stays subscribed. I hope that MTab will permit us to have options like stay in sync, or be lazy, like only grab things when you're asked for. Basically all the kinds of options that a file system has when you mount it.
Yeah. It's starting to bug me that the address has the peer in it.
That's a good point, actually. That's a very good point.
Like it's starting to feel a little bit like there's maybe.
That's cool. So all I need to do is, because my terminal code doesn't work, I'd just go add address, and then I'd specify the string, and then internally I would process that to map it back to the peer ID.
Right.
Because that's
or
all
that there might only be one, right? Like when you go add peer, like I guess it's assuming that what's already in your MTab is the place to reach out to try to find the peer.
Yeah. So it's it collates everything it already knows with what you just told it to see if it's got some new avenues to search to meet your intent.
Right. Does it? Is it a valid address, multi-format address, if you just remove all the IP4, like IP address TCP/P2P? Like, is a peer address a valid multi-address?
No, a peer ID is not a valid multi-address. A multi-address may be provided that has no peer ID on it, I think.
Okay.
So I'd basically just store the multi-addresses without the peer ID under the key of peer ID, and then build them up on the fly.
Right.
I think.
Yeah, it's fine. Either way, I think like watching you do it here just makes me feel like maybe there's only one thing here instead of two.
You're right. Yeah, there is only add multi-address. And I can figure out what the peer ID was from that. There is definitely there's a mapping between chain ID and peer ID. That's required, because you just otherwise you could, if it was a public chain ID, you could use a DHT to look up that information. Yeah. But either way, you need to either tell the system what the peer ID is to use for this chain ID, or have a discovery mechanism implemented.
Right. And add peer, the interface there is like you need to know which peer you're trying to add the chain from. Like, is it possible to just add a chain like without knowing what peer you're like asking for?
Yeah, you can leave it unresolved, but you're not going to get any data for it.
Right.
Like, yeah, you can build it up over time as more information is given to you. You can also programmatically control MTab. So a covenant, when it deploys, can ask to mount something. Like it can have within it the address and peer ID and some information that it wants to put into MTab when you install the app.
That's a cool way of like bootstrapping, actually. Yeah. Like loading code to Bootstrap. I think because the code is like something that's probably a little bit more public.
Yeah, code's definitely more public than instance. Yeah, and then, well, that's it basically. And then once you've done mount, the subscription process kicks off. I got a unit test that does it. Yeah, where are we? Here. This, yeah, basically it runs through everything and connects. But the downside that I want to show you is oh, here we go. The downside is this 796 milliseconds here, because turns out the structure of the pulse is actually has a huge impact on how long it takes to fetch. Because if I fetch the pulse, I can only know when I get the response back, I can only know the next layer of hashes to ask for. And then I got to ask for them again. And then, so that round tripness before I consider the pulse complete is, I mean, this is only running on localhost, but it's about 600 milliseconds to pull down a pulse,
Right.
which isn't great.
No. Can you be a little more optimistic than that? Like,
Yeah.
When you go through MTab, you're asking a foreign computer to send you stuff back.
Yeah.
Right?
Yeah. Well, if it's in MTab and I've configured it to stay in sync, in the background, the engine will pull it. So when you go to execute anything that depends on that link, it will always work on whatever the last known one was. So there's no delay in your local processing. It's just that if something remote happens, you're always about 700 milliseconds behind on what the latest thing is. And that's a combination of the structure of the pulse plus the overhead of BitSwap, which is the IPFS peer grabby thing, which I wanted to keep using because when you get a swarm, it's great. But when there's one-on-one, maybe it could be faster.
Is it impolite to ask the foreign process to like pre-assemble the pulse for you
and push some stuff to you? It's not impolite, but
would it be faster?
It does open the door to you being flooded off the network if that's allowed.
Right.
And you know, you could drown yourself out, I guess, by just asking for things, the wrong things.
Because I assume most of that 796 milliseconds is just network latency for the nested data in the like. It's not even the fetch time to get the stuff is not that expensive, because I assume the foreign validators usually got it in RAM, right?
Yeah, the foreign validator usually has it in RAM. I can show you what's actually happening here. These are the BitSwap messages. So this is from inside of libp2p. That might have been a bit too much. It's very, very chatty. Because it does like notification as well. Let me just turn on BitSwap engine.
Right.
So I guess you can sort of see here.
That's so weird. Like half of them are 100 milliseconds, the other half are 0.
Yeah, it's just because I think why it's coming in as 0 is that this came in as a batch.
Oh, so it is already doing that a little bit. It's already a little bit optimistic.
Well, it does batch them, but it's just it doesn't know what the next batch to ask for until it got the previous batch.
So it's like a breadth first tree kind of thing.
Yes, breadth first. I don't. It can't really be. It's it's basically it's depth first and parallel, which is the same.
Right.
So I think I just need to redesign the pulse a bit to accommodate that, right? Because having like going pulse, then provenance, then DMZ, then state.
Yeah, you could just flatten it all out on the root of the pulse.
Smush it. Yeah. Yeah, right. And then it's like it would reduce the round trips, because what do we got here? It looks like 1, 2, 3, 4, 5, 6. It looks like 8 round trips to get a complete pulse, which is a bit cruel, right? Like it's not it's a bit of a dick move, really. Yeah, I'll look at flattening it, because it wouldn't really add very much to the overhead.
It's going to be a like brutal refactor, though, I think, on it.
No, it's cheap. It's cheap because like look at how lonely the pulse itself was in terms of this. It's just got two keys in it, provenance and signatures, whereas I can refactor it to just flatten everything below it.
You know what? I think like don't be too much in a hurry to do that, because I think there might be consequences, basically. I think there's a lot of reasons to keep things structured in a way where, like, if I only wanted to pull this one level, like getting provenance and signatures together without asking for a deeper query than that is like also useful, right?
Yep.
That like I guess you could just ask for what you want, though, right?
Yeah, there's that too, I guess. And that was kind of the purpose of the state tree, so I could get just the state of the entire app complex. Anyway, I'll keep at it. But that was the demo, and that was the thing I wanted to check with you, was the mount concept and the fact that pathing is now like security related.
Yeah, I got to chew on the pathing thing a little bit, because
so like some things to worry about are like, because it's pathing, you can change it. So the address at the end of a path in one pulse may be different to the next. And so at the moment, I'm like, well, if it goes through MTab and you get something different, then I'm gonna throw it, because I'm like, that's not right.
Yeah, like it feels like if it's going to become a system primitive concept, like, does it make sense to include the path as like part of the chain state now?
It is already, though, because like the list of children is what the path is constructed from.
Right. And the children are in, like, they're made in chain, right?
Yeah. So it is, path is derived from chain state, but one of the problems is the mutability of it. Like, what does it mean to talk to a chain at the end of a path and then it changes later? Like, do you just stick with what you first got, or do you update? Do you invalidate everything in flight and update, or what?
Yeah, I mean, I don't know. I guess like the thing in the MTab and your shell chain's view on what the paths are is really the mutable thing, right? Like maybe there's just a rule in there somewhere that says that, like, I can't call things a path than what they call themselves.
Well, there's definitely so I've introduced and I've put into Obsidian the concept of the supervisor tree.
Yeah.
And that is basically the I'll pull it up. There's a definite tree back to root of parents and children always.
Mhm.
So this is the supervisor tree path. Basically, when you use a path, you have to be, for it to be, it's always expanded out to be its system path. So if you had some symlinks in there, it's going to be resolved.
Right. Right. There is no mutability then, right? Like the type of mutability you're talking about is like if I'm a chain and I'm making a new child and I'm going to stick it at the same address as my other child.
No,
Then
no, it's about making a new child, deleting the current one, and then making a new one at the old name.
the old name, yeah, not
That's
address.
the
Right?
problem.
So, yeah. So, but like if you're going to do that, then I think the thing you just need to maintain basically is that if somebody's going to consume that on the other end through a mount or or in their shell, like they just need to follow you. Like they have to listen to what you did. Like basically you shouldn't divorce the shell's concept of path at all from the app complex's concept.
Okay, so let me check something with you then. If I made a connection to an old child, I made a request to it. The request has not been settled. That old child is replaced with a new child. The behavior that I would induce as the engine is that I would detect the chain swap for that path. I would invalidate every unsettled request with a rejection.
Yeah, okay.
And then I would, from that point on, any new requests would go to the new chain.
Yes.
Is that valid behavior?
I think so, right? And like it's always requests versus the app root hash, right? So it should be possible to tell like when I need to invalidate back to.
I would invalidate everything.
That's unsettled for sure.
Yeah.
But you would probably want to question as well things that were processed in the meantime.
Before? No, I think if it was processed before, that's fair game.
Is it possible? There's someone running around behind you. It's funny. Is it possible to? I guess there's one thing that I'm having trouble wrapping my head around here, which is if I sent an action and the chain was already changed, and it processed that action anyway, because say for instance,
you sent it and then it changed before it landed?
Yeah, I guess it couldn't because it would be sent to a chain ID and not an alias, right?
Yeah. So it's at transmission time, the path is resolved to a chain ID. If that chain ID has changed relative to the root hash, then a rejection occurs.
Yeah. Okay.
Is there any value in having the ability to follow a chain, even if it gets renamed in the path?
Would it? I mean, so if it's renamed in the path, it means that somebody in the app complex renamed it, right?
Yes.
And like generally, it wouldn't be able to repath it to anywhere except for somewhere else in the app complex, right?
It should be able to transport it to a new app complex.
That seems like an extremely special operation.
It's not that alien, I would say. If, for example, I am running a nail salon
Mhm.
One of my customers wants to move to another nail salon,
Mhm.
I would want to move their customer record over to the new nail salon app.
Mhm. Yeah, yeah.
So in that case, if I could transmit to address only, so if I allowed a hard link that was to an address, and then the path was considered a hint, then so it's like the first time I make the connection, I use this path to look it up,
Mhm.
and then it's just simply maybe it's a warning if the path changes later, but I stay hooked to that address. It'll just mean that I won't know how to look it up, and I'll need to update my path information to reflect the new path, as opposed to updating the address to reflect the new path.
Yeah. Yeah, I mean, the
Yeah,
other
I
thing
think that works.
you could argue that it's polite as a developer in that kind of application where you're teleporting records around various universes that
Yeah,
you should leave a redirect at the old
it's
address.
right, right. It's basically yeah, you're right. It's a redirect.
But I don't think this is the only case. I think we need to maybe be a little bit exhaustive about like
Yeah,
path change operations and what they're useful for.
yeah, I know.
Um, it does I really really like the idea of a path being like treated fully as um, like a human readable name for a chain,
Yeah,
like that the chain ID is the only real thing and the path is less real.
yeah, I know, and that's why I was wanting to talk to you, because I'm sort of compromising that a bit.
Mm. I don't know that you are though, right? Because like if you think about it, the decision you're talking about right now is like how does my shell chain behave based on what its internal state of the paths that exist inside of it are, right? So like you're still making a decision based on your local like picture of what that all looks like, right?
Yep, yep,
Um,
that's true. That's true.
I mean, the fact that everything's kept in pretty tight sync with each other means that like that your local picture should reflect reality really well. But
Mm.
like I don't view this as like an insane choice. It's like if I think this thing is in a remote place, then I'm going to use a remote protocol to try to attach to it, right?
Yes, that's true. Yep.
Um,
Yep. And so if I'm using, so pathing would be more a local protocol,
yeah,
and like, because the mounts don't use paths. The mounts use chain IDs strongly,
right, right.
but you can optionally um, follow a path from a mount. It's just that the mount point is by address, and then everything
Mhm.
below that is by path.
Right. And I think there's like the confusion is coming from the fact that there's two things here that are called paths, right? One is the like the parent-child relationships in the app complex, and the
Right?
other is my picture of what those are in my shell.
They are the same.
They should be. I mean, they should be. It's really, really, I think, a big vector of confusion if they aren't.
Yeah.
Um,
No, they're absolutely the same.
mhm. um,
Hmm.
I mean, unless you wanted to allow users to rename stuff.
Well, when you do it, you need to do it synchronously. So it's like, according to this pulse in the root pulse chain,
Mhm.
this is the new name.
Right. Yeah. Okay. So, I mean, if that's the way it works, if it's always a lead and follow thing, like if the source of
Yeah,
truth of the paths is always the app complex,
yeah.
then
It's
there's not a
always
problem.
it's the source of truth is always the root pulse in the app complex,
Mhm.
and then you have to walk down. That's the authoritative path.
Right. And everything that you
Um,
see in your shell is just like a guess at what that might. Anyway, sorry, let me take you.
the in the Linux file systems, they use inodes and paths. So a path resolves to an inode. For us, it's chain IDs. But the view of a path is strong within your app complex. It's never wrong. It's always relative to the root.
Right. But like you're always looking at a stale version of reality, right?
Yes.
Um,
but that is that is authoritative. So.
Right. Yeah. It means at that point in history, yeah, I see what you're saying. So relative to the last like route that you saw, you know that everything inside that path is at that location.
Yes, correct. Absolutely. Correct. Now it may have changed, but until it's reflected in the route, it hasn't.
Right. Right.
It's changing. It has not changed.
And if you're like super far out of date, like that everything's in a different location now because the app has changed like that much, then
you can't be out of date because it is part of the function of the engine to look at route and guarantee that when it's making a new pulse for a child, it's using the latest route.
Right. Yeah. Okay. I don't think there's actually a problem here. I think like when you say that you're going to use Mount like to resolve chain IDs remotely and change the behavior of how you connect to them, like I guess there's probably like as long as you follow that same rule of like all the paths that I follow from that remote connection are
relative like to that route, authoritative based on that pulse hash.
Mm-hmm.
Yeah, okay. That seems reasonable. Okay. I am less worried now.
I mean, I don't know. I think it's like remember that most of the time when I thought about aliases, they were just like names that I was giving to this thing.
Yeah, this thing. Local
code. And like, I think paths are actually like a way more useful system to name things with because there's a built-in sense of hierarchy and hierarchy is useful.
And its performance as well. You know, like a lot of things can happen down low that have only one result up.
Mm-hmm.
So you can have like huge app complexes with massive parallel throughput, and the pathing is still used to jump up and down between layers of the system.
Right. In fact, you could probably go so far as to say like that's the ideal way to design an app, and the system is like lots of things happening in the leaves and nothing happening up at the root.
That's the whole idea. Yeah, absolutely. Yeah. So right now I'm working on connecting and being able to write to a remotely mounted chain system.
Mm-hmm. I'll read through the code when you commit it here. I think I'll commit some code too, and hopefully my brain's starting to work again.
Sweet.
So
cool, man. Yeah, that sounds cool. That sounds real cool. So I'll just carry on. I want to get something deployed at the customer's site, hopefully this week, where it's just basically, here's this web page, you can mount your app, and you can see the beginnings of your application. I finally made the working on the web page library, so the thing that turns the blockchain into React components. Mm-hmm. And with this new engine design, it's so much simpler. Like subscribing to streams of pulses using async iterables, all that stuff is just meant for much less complication in the web front end library. So hopefully you can take a look at that and see what I mean, and see how it looks to you, but it's getting better.
I actually am so keen to see like the GUI part of it. I love GUI work. I think I prefer it much more to back end work.
Yeah, me too. And that's sort of this point of the system is that we can sort of be GUI fast, like GUI
Mhm.
really fast.
Mm-hmm. Yeah, I'll take a look.
Okay, all right. I better bounce in. Is there anything else that you wanted to cover?
No, I don't think so. Thanks
Sweet.
for the demo.
Hey man, thanks for the time.
Mhm.
It's great to have some reassurance on
Yeah,
the Curly decisions.
it's cool. Like, I think it's so close, man. Like,
It's close, man. Yeah, it's real close, real close. Yeah. Okay, all right. I'll sign off. I'll see you later.
see ya.
Bye.
Bye.